Alright, what's up everyone? Let's go over these next notes here. So, TSI day 5. First things first, we're going to be graphing inequalities. So, if you are graphing this symbol or this symbol, then your line is dotted. Okay? Dotted lines. Maybe you're not sure what I mean, like, we got a graph. And then when you graph the line, it's going to be a dotted line. Okay? If you're graphing that symbol or this symbol, that little line underneath helps you know that it's going to be a full line. Right? So if you're doing a line, if it's this symbol here or this symbol, right? Then you would graph just like a full line. Like, oh, there you go, full line, a regular line. Now, the shading part. If you graph this symbol or that symbol, this means greater than. Well, this means greater than. And this means greater than or equal to. So, if you're going to color something that's greater than, you're going to color above the graph or to the right. You color above or to the right. If you see the greater than symbol, you color above or to the right. And vice versa. If you have the less than symbol, right, this is less than or equal to. If you have either of those symbols and you have to shade, you would color / shade below, because less than means below or to the left. And I'll go over an example right now what I mean by that. So here's our first example. Right, so here's our first graph. Y is less than or equal to -1/2x minus 3. So we're going to start here like we did last time. Remember, this is the y-intercept. Start there. So that's the x-axis, is the y-axis. So at the y, you put at -3, put a dot. -3, right there. Because that's the y-intercept. Now, this, if you remember, is the rise over the run. And our rise over run is -1/2. Since the rise is -1, that means you're going to go down 1. And then since the run is positive, 0. Since the 2 is positive, you're going to go to the right 2. Okay? So go down 1 to the right 2. Down 1 to the right 1, 2. Another dot. Down 1, right 2. Another dot. Down 1 over 1, 2. And so forth. That also means that I can go up 1, left 2. Up 1, left 1, 2. Up 1, left 1, 2. Let me make my line there. Oh yeah, I almost forgot. Now, the symbol has a little line. If you have the little line, then you make a full line. Just a regular line like we're used to making. There's my regular line. Okay. Remember, if it doesn't have that line, then you make a dotted line. We'll see if the next example has one so you can show you. But since it has that line underneath, you make a full line. Next, the symbol. What symbol is it? Well, that symbol says less than or equal to. Less than means to color below or to the left, depending on the question. So I'm not going to color above, I'm going to color below the line. This is below the line. So all of this down here would be shaded. Okay, that's how it looks on your thing when you graph inequalities. Why did I color below the line? Because that says less than. Had it said greater than, I would color above the line. Here's our next one. So again, first, we're going to start with this number. That is the y-intercept. It's -5. So on the y-axis, go to -5 and put a dot. -5 right there. Then my rise over run. My rise and run is -3. What should my run be? A 1. So since it's negative rise, that means you're going to go down 3. And since my run is +1, you're going to go to the right 3. I mean right 1, sorry. So down 3 to the right 1. 1, 2, 3 to the right 1. Now you notice I don't have any more graph here. So then what do? Well, you can make a line right there. You only need 2 dots to make a line. Or you flip this around. Instead of going down 3, you go up 3. But you got to go left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. 1, 2, 3, up, left 1. And then you can make a line there. Nope, that's a 0. Messed up already. Pay attention. You all excited to graph a line, I did it wrong. The symbol right here. Does it have a line underneath? No, there's no line there. Since there's no line on the bottom, you don't make a full line, you make a dotted line. Or like a slash line. There you go. Dotted line, slash line, whatever. Don't make a full line since there's no line under there. Now, this symbol is greater than. Greater than means to color above or to the right. Here, if you're not really sure which one's above, to the right helps you. Color to the right of the line. There you go. All that would be colored in. Then these crazy lines here. It's just like the other one that we did. You go to the x-axis and you put a dot at 3. X-axis, go dot at 3. 1, 2, 3. Right there. Now if you forget x lines go vertical. So they make a vertical line right here. Now, does it have a line in the bottom? Yes. So that means our line will be a full line, just a regular old line. There we go. Now, the symbol. What symbol is this? It is less than. Less than means below or to the left. So color this to the left. So everything here will be colored. Our last graph. Y is greater than 3. So on the Y, go to the 3. Make a dot. 1, 2, 3. right there. Now, is there a line on the bottom here? No, which means our line would be dotted. And the y lines go side to side. So make a horizontal line, but dotted. Or slashed, whatever. There we go. Next, a symbol. Greater than. Greater than means above or to the right. I can't color to the above. I can't color to the right here, but I can color above. So color above. And that's pretty much how you graph the inequalities. Right, next. Next is going to be more review over exponents. So more exponents. All right, so then in this question here, I didn't even number them. I did 4 graphs, so this would be number 5. This would be number 6, 7, 8, 9, 10, 11, 12, and 13, 14, 15. All right, that's it. 15 examples. All right, back to number 5. Exponents. We're multiplying. Remember that when you multiply the bases. So negative 3 times 3, that would give me negative 9. But the powers, you're going to add them. Now look, I have n3. Look for another n. Oh, here's another n. So you add them. 3 plus negative 3. What's 3 plus negative 3? That's 0. So then I don't have to write n anymore because I'm going to have n to the 0. And n to the 0 is just 1. So those are gone. So the n's go away. I'm still left with my m, so just bring it with you. M to the 3. Number 6. Multiply the bases. What number is here? Oh, there's a 1. So 1 times 2, that gives me 2. Now the letters. I have u3 here. Where's the other u? Oh, it's right here. U negative 3. Oh, just like the previous question. Should have made it different. Oh well. 3 plus negative 3. 3 plus a negative 3, that's 0. So then I would have u to the 0, which is just 1, and I don't have to write that. So this is gone. The u's are gone. Now the v's. That's a v with a negative 4, and that's a v with a negative 3. You add them, because when you multiply, you add the exponents. Negative 4 plus a negative 3. But negative 4 plus negative 3, that is negative 7. So then you have v to the negative 7. Are we done? No, can't have negative exponents. So I got to fix it. If it's negative on top, where do you kick it? Kick it to the bottom. But what bottom? You make it a fraction. So now all this goes to the bottom. So the 2 stays on top. Nothing wrong with the 2. Except now the v goes to the bottom and the 7 is now positive. And that's our answer. Hey, look. Division questions. We just did one. Number 7. When you divide the big number, or the bases. 2 and 3. Can you divide 2 and 3? No, they already reduced, so leave them alone. Nothing else you can do. So 2 divided by 3, that's still going to be 2 divided by 3. You can't do anything, leave them alone. Now we get to the letters. Now we have yx and xy. It's annoying, right? So which one do you do first? Remember, you follow the alphabet? So I'm going to do X first. Just X, Y, Z, X first. X. Negative 3 and 3. What do you do when you divide? You subtract. Negative 3 minus the bottom number. The bottom number, that's an ugly 3. So negative 3 from here minus the bottom number, which is 3. Negative 3 minus 3, that's negative 6. So then my X is a negative 6. I'll fix that right now. First, let me just do the exponents. Now we do the Y's. There's a 1 right there. So there's a Y1 and a Y negative 3. What do you do when you subtract? When you divide, you subtract. It's 1 from the top, minus because you need to subtract them. And what number is on the bottom? A negative 3. A minus and a minus, that turns to a plus. So that's a 4. So then we have a Y to the 4. If you notice, we took all the numbers from the bottom to all the exponents to the top, which is fine, right? If everything was positive, but you know that we have a problem right here. We cannot have a negative 6 on the X. So you leave everything alone except you take this X negative 6 and you move it to the bottom with the 3. So it's 2 on top, Y to the 4 on top, 3 on the bottom, and now the X to the 6 goes to the bottom. And that's your answer. Number 8. There's a 1 right here. So 1 divided by 4, well, that's going to stay 1 and 4. Now we have X and Y's, remember. So I'm going to do the X first. There's an X right here. Is there an X over here? No. So I'm going to leave X to the negative 3 on the bottom for now. Even though I can't have a negative. And how do you fix the negative? You kick it to the top, but I'll do that later. Let me do the Y's first here. I have a Y2 and a Y negative 4. So subtract those numbers. You have 2 minus, now put the bottom number, which is negative 4. 2 minus minus 4, that turns to a plus, so we have 6. So we have Y to the 6. Now fix it because we know this can't be negative. So all of this goes to the top. I'm not going to write the 1 anymore because I have stuff on top. I have X with a positive 3 on top. I have a Y with a 6 on top. And on the bottom, I still have the 4. You can put the 1 if you want, but we don't really need it. And then that's your answer. All right. The next part here is solving radicals or non-perfect square roots. Solving non-perfect square roots. Now, what do I mean non-perfect? The square root of 36, that's just 6 and negative 6. This is a perfect square root. There's no decimal. It's perfect. It's ready to go. But we're going to get, not everything's perfect. We're going to have non-perfect ones. Okay? And these are the numbers you need to know. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Does it go more? Of course it does, but hopefully you don't have to use them. Now how do I get those numbers? 4 is 2 squared. 9 is 3 squared. That's 4 squared, that's 5 squared, and that's 6 squared. You understand what I'm doing? That's 7 squared, that's 8 squared. That's 9 squared, that's 10 squared, and this would be 11 squared. And that's 12 squared. 0. Silence your phone, nah. So, do you have to remember these numbers? Do you have to memorize them? No. They're easy to get. How do you get them? Well, it's 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. Why do I need to know them? Who cares? Why? Well, they helped you solve, or they're going to help you. Oh no, I didn't want to do that. That's a 0. Write that again. They help you solve non-perfect square roots by using the perfect square root numbers. Let me show you how. 3 examples, okay? Once it seems a little confusing at first, but then it's like, oh, it's easy after you get it. So let's look at this. Square root of 20. If you put the square root of 20 in the calculator, it's going to give you a decimal. The TSI does not like decimals, it wants perfect answers. So we're going to figure it out. The square root of 20. This is what we do first. Once you figure out that this number is not perfect, you start to divide it. You do 20 and divide. That's just what we do. We divide. But by what numbers? These numbers. And you keep on going until you get an answer. Again, this is the first example, so it's going to be fairly simple. 20. What's the first number we divide by? The first number I wrote down? 4. How did we get 4 in case you forgot? It's 2 squared. Can you divide 20 and 4 and get a regular whole number? Yeah, 20 divided by 4 is 5. All right. Now we're going to use that. This is what happens. Because I only wrote down the 20, right? But I forgot the square root sign. So now I'm going to bring it in. Okay. So that means, you know that you can write down 20 is equal to 4 times 5. Because 20 divided by 4 is equal to 5. So 4 times 5 is 20, right? That's just simple math. We're just using the properties, right? So it's the same thing as saying this. Okay? Same exact thing. We're just putting square roots because now we have square roots. Now, what is the square root of 4? The square root of 4 is 2. And negative 2, but we're only going to use a positive. Okay? I know there's a negative, but we're only going to use the positive. The square root of 4 is 2. What's the square root of 5? There is no square root of 5. And you're done. The square root of 20 is equal to 2 square root of 5. Let's try one right here. Something where it doesn't go perfectly right off the bat. So 108. 108 is not perfect, so start dividing it. Okay, so 108. And which one do you divide by first? What's the first number we try? You try 4. So you put 108, then you divide that by 4, and if you have to do it old school. There's no calculator, right? You're gonna get 27. Yo, hey, I like 27. That works. Yes, but if you notice, when we divide it over here, we got 5, and 5 is a nice single digit. I don't want double digits, so let's try another number. So that's a maybe. 108. What's after the 4? Remember up there, the numbers wrote down? It was 9. So then, I don't know what that meant. 108, you divide that by 9. And we get 12. Hey, from 27 we went to 12. Better. Let's try another one. What's after the 9? Well, that's 2 squared, that's 3 squared, so 4 would be 16. If you divide this by 16, you get a decimal. So that means automatically 16 doesn't work at all. That's wrong. So right now 4 maybe works, but 9 is even better because it gives you a smaller number. You keep on going until you want to get the smallest number we can get. So then 108. After 16, it was 25. See, like, I hope you understand that just by looking at that, like, that doesn't make sense. 25 doesn't go to 108. That'll give me another decimal. Then it'll be 108. After 25, it's, 36. And you're finally going to get 3. There's my single digit. That's what I'm talking about. If you're asking yourself, is there an easier way to do this? No. You just have to go through all the numbers until you get this. That's how you do it by hand. All right? Even if you put on the Inspire, it doesn't give you an answer, it gives you decimals. I mean, you get a fancy calculator on the internet, yes it will, but you can't use it. So regardless, you have to know to divide by 4 first, then 9, then 6. You keep on going until you get a single digit. And I got it right there. So then I'm going to rewrite this. 108 is equal to 36 times 3. Since I never wrote the square roots, I'm going to bring them back in. And then one of them should always be perfect. What's the square root of 36? It's 6. And I know negative 6, but we're not going to use it. So it's 6. And then bring down the square root of 3. And you're done. That's the answer. The next one here, number 11, 54. 54 divided by 4. That gives you a decimal. That doesn't work. What's after 50? What's after the 4? It's 9. What's 54 divided by 9? 6. Hey, there you go. Single digit already. Perfect. That means that 54 is equal to 9 times 6. Bring in the square root signs. The square root of 9 is 3. And negative 3, but we don't need it right now. And the square root of 6. And you're done. Alright? That's just how we do those questions. Here we're solving for n. So we're solving rational functions here. Solving square roots. Solving square root equations. Okay, so remember, is there anything in front of the square root? Yes. Is there anything afterwards? No. So then we need to get rid of the one in front. It's a 6. How do you get rid of the 6? You subtract 6. Square root of n is equal to 16 minus 6. That's 10. Is there anything in the front? No. Is there anything afterwards? No. Perfect. Now, how do you get rid of the square root? Parentheses 2, you square it. That 2 cancels all of that. So it's only n. 10 squared means 10 times 10, that is 100. And you're done. Number 13. Uh-oh, 2 square roots, what the heck? Fine, whatever. So all of this is the square root. Is there anything in front of it? No. Is there anything after, right here somewhere? No. So this one's ready to be solved. Next one. Is there anything after this? No. When I mean after, like, is there a minus 4? When I say before, is there like a 6 right here? No, there's nothing in the front, there's nothing afterwards, right? These are perfect. So they're both ready to be solved. How do you get rid of the little square root? You take the 2 of both sides, the exponent of 2. This 2 cancels all of this. So we have 2m minus 3 is equal to, and then this 2 here cancels all of this, m. So then we have m's on both sides. You want to get m's with m's, so to subtract 2m. Negative 3 is equal to, what's 1 minus 2? Well, 1 minus 2 will give me a negative 1m. M's almost by itself. Move the number in the front. How do we get rid of this negative 1? It's being multiplied, so divide by negative 1. Those cancel. And a negative 3 divided by negative 1 gives you a positive 3. Oh, just 2 more questions. 14, 15. I'll do the rest in a little bit because the bell's going to ring. Anyways, we're back. Alright, let's finish this up here. So number 14. Number 14, we're going to solve for the letter B, right? So there's a 5 in the front. So how do I get rid of this 5? Remember that it's being times. I see some of you still want to do a plus here, but it's not. It's divide by negative 5. Divide by negative 5. 125 divided by 5. 5 times 2 is 10. 2 and 5, so 25. 25. A negative over negative is positive, so b squared is equal to 25. Now, the b is almost by itself, but there's a 2. How do you get rid of the 2? What gets rid of the squared? You remember? It's the square root. If you do it to one side, you have to do it to the other. So the square root and the 2 cancel. So it's all gone. So b is equal to, alright, so the square root of 25, that is going to be 5 and negative 5. 15 here. You want to get the v by itself, right? So the problem is, though, there's a 3 in the front and there's a negative 8. Don't mess with nothing here on the v first. You always check if there's something afterwards or before. So before the v we have the 3, and after the v we have the negative 8. And what you do is you always get rid of the plus or the minus first. That's always what you do first. So negative 8. How do you get rid of a negative 8? U plus 8. Cancels. 3v squared is equal to 8 plus 4 will give us 12. Divide by the 3. V squared is equal to 4. Get rid of the squared, and that means you take the square root of both sides. So this 2 and this cancel. So v is equal to the square root of 4. The square root of 4 is 2 and negative 2. And that's it for the notes. Alright, laters.